folks, we're on day 4 of transformations. We're going to talk about our fourth and final transformation for the year, dilations. Dilations on the coordinate plane. So first things first, here we are. This is what we want to know by the end of the lesson. We want to be able to say, I can enlarge and reduce figures by any scale factor k. Normally we call the number which we are enlarging our figures by or shrinking them by, we call that scale factor. The letter k usually represents that number. And you'll see what that means in a second here. Secondly, I understand that when a dilation takes place on the coordinate plane, or when I shrink an object or a figure, or when I dilate or enlarge the figure, the image, remember that's the second figure, the new figure, is similar to the original figure. Talk a little bit more about that right down here as well. So when performing a dilation, this is where you have to fill stuff in. When performing a dilation, you enlarge or reduce a figure by a certain amount. That certain amount we call the scale factor, with respect to a fixed point called the center. So on your coordinate plane, which is not going to be very nicely drawn, you might have a triangle that's pretty big out here, and if we're going to dilate it by a scale factor of 1/2, this thing is going to, our new figure is going to be smaller than this. We're essentially cutting it in half, and it's going to shrink towards the center, okay? That's the center. We are dilating our triangle with respect to the center or the origin. We usually use the letter k to represent the scale factor. So if our scale factor k is 2, or if our scale factor k is 1/2, we should always know that k represents that scale factor. That's how much we're enlarging it by or shrinking it by. And we'll do a couple in a minute here. In order to perform a dilation, simply multiply the scale factor by each of the coordinates. It's actually very simple, but I underline that part because that's telling you exactly how to perform the dilation. So you should be referring back to this thing right here, this underlined portion, once you actually start working. So a couple things to note. If k is greater than 1, that means if your scale factor is more than 1, so if it's 2, 3, 4, 5, 1.5, then your dilation is going to be an enlargement. Because what that means is, if I'm still talking about this triangle, if I take each of the coordinates and I multiply, let's say my scale factor is 2, it means I'm taking each of my coordinates and multiplying them by 2. Well, of course, each of these numbers is going to become larger, so my shape is going to be larger. Secondly, these three things are pretty important, okay? B, if k is between 0 and 1, then the dilation is going to be a reduction. So I'll give you another example. Okay, let's pretend we're dealing with the same triangle, and your scale factor is just 1/2, or 1/3, or 2/7. Those numbers are between 0 and 1. What happens when you multiply numbers by 1/2? Well, you're really cutting the number in half. So that means these numbers are we're going to shrink this way. But our triangle is going to shrink. These points are going to get closer together, and they're going to be somewhere down here. Okay? So when you multiply numbers by a fraction that's between 0 and 1, the numbers get smaller. Lastly, if our scale factor is exactly 1, then our dilation is really just producing a figure of exactly the same size. Okay? Because you're just multiplying everything by 1. Please note, this is different from your other transformations. Please note, the image, meaning the new figure, the image is similar to the original figure, and the orientation remains the same. That means, in our other transformations, reflections, translations, okay, you performed that transformation, the figure stayed the same size. Like in a translation, all you did was shift it to the right, or shift it right and down. But it was exactly the same size. Exactly the same figure, exactly the same size. You just moved it. Okay, that means that our two figures were congruent. They were the same. This word similar does not mean that they are exactly the same. The image is similar means, hey, it has like the exact same angle measures as the pre-image, and it has proportional side lengths. So if this side length is cut in half, this is exactly half of this one. But that also means that this one is exactly twice the length of this one. And this one better be half the length of this one. So those side lengths better be in proportion to each other. This guy is exactly the same as this guy, he's just smaller. Or, if it's an enlargement, then he'll be bigger. So if you've ever seen Austin Powers, it's kind of like Dr. Evil and Mini-Me. Okay? They're exactly the same, just one's bigger than the other. Now, we've only got 2 examples for you today. So, a figure has vertices 2, 4, 2, 6, 8, 6, and 8, 2. Find the coordinates of the vertices of the image. So that means, please, we're trying to find the vertices of the new figure after the figure has been dilated by a scale factor of 1/2. So remember, back on your other page, on our notes, it says, in order to perform a dilation, simply multiply the scale factor by each of the coordinates. So like I said, you're going to refer back to this direction every time you perform a dilation. So if you just have to multiply the scale factor, that's this guy, by each of the coordinates, this should be pretty easy. So let's write these out just so we can see it all. So if j is 2, 4, j prime is going to be 1/2 times 2, which is 1, and 1/2 times 4, which is 2. So there's j prime. Let's do k prime. K was 2, 6, so k prime is going to be 1/2 times 2, which is 1, and 1/2 times 6, which is 3. So if you notice, I'm just taking our scale factor 1/2, and I'm multiplying it by every x value and every y value in my coordinates. Let's finish this off here. M, which was 8, 6. I should have written these down before I started the video. Sorry about this. So 8 times 1/2. So m prime is going to be 4. And 6 times 1/2 is 3. And we'll do n prime right over here. Whoops. Let's scratch that out. We're just doing n is 8, 2. And now we're multiplying it by our scale factor. We're getting n prime, which should be 4, 1. Okay. You're not always going to cut your original numbers in half. This is based on what your scale factor is. I'm shrinking this original shape, my pre-image, by a scale factor of 1/2. So it's 1/2 times each of my original values. So let's graph these points. J prime is 1, 2. K prime is 1, 3. M prime is 4, 3. And N prime is 4, 1. 1, 2, 3, 4, 1. So if you notice, there's our new figure, and you could easily, label those points. Okay, so there's our new figure. Obviously, it's a lot smaller because our scale factor is between 0 and 1. And if you notice, it shrank, but it also moved towards the center point, the origin, because we're shrinking it by a scale factor that is centered at the origin. So it's going to shrink this way. Or if your figure enlarges, it's going to enlarge out a little bit. Okay? So those are key things to look for. If that's not happening, you might need to double check your work. So it says find the coordinates. I guess you didn't even really need to graph that. Your answer would have been those 4 coordinates, since that's what we're asked to find. Now number 2 says a polygon has vertices A, negative 1, 1. Let's graph that. B, 1, 1. C, 1, 2. Okay, those are our 3. Dang, man, I'm off here. Let's get that. Let's get rid of all those and let's try this again. Negative 1, 1. 1, 1, and 1, 2. Nice one. It's much better. Okay. So we've got ABC, our polygon right here, our triangle. It says graph the polygon, which we did, and the image of the polygon after a dilation centered at the origin by a scale factor of 3. So that means take our original points, and since our scale factor is 3, all we're doing is multiplying our points by 3. So I'll write all these out. A was negative 1, 1. B was 1, 1. These are perfect guides for you. We're going through these examples, so when you have these exact same types of problems on your homework, you have these examples worked out for you, so you need to refer back to them. Okay, so multiplying negative 1 by 3 gives us A prime. Whoops. It's going to be negative 3, and 1 times 3 is 3. You should have already realized that since our scale factor is more than 1, we're obviously going to be enlarging our figure. Our image is going to be bigger than the original, than the pre-image. B prime, once again, 3 times 1 and 3 times 1 is going to give us 3, 3. And C prime is going to give us 3, 6. So let's graph these guys. 1, 2, 3, 1, 2, 3, negative 3, 3. That is A prime. B prime is 3, 3, 1, 2, 3, 1, 2, 3. And C prime is 3, 6, 4, 5, and 6. Obviously, A prime, B prime, C prime is much larger, as it should be, since we're multiplying everything by 3. And if you notice, we did enlarge it with respect to our origin. So once again, we enlarged it, and it's going to bump out a little bit. It's going to be further away from the origin. Remember, if you're shrinking, you're going to get closer to the origin. Alright, one more slide here. Just want to double check what we've done today. It says when enlarging or reducing the size of a figure, so when you dilate it by any scale factor, you simply multiply the scale factor by each coordinate. We did that in both of our examples. Makes it pretty simple. Even if your scale factor is 2/3 or 7/9, okay, you still take the scale factor 2/3 and you multiply it by each of your x and y values in your coordinates. Also, the image of a dilated figure is not necessarily congruent to its pre-image. Okay, the only time a figure that's dilated will be congruent to its pre-image is if your scale factor is 1. Otherwise, your new image is either going to be smaller than or larger than your pre-image. Therefore, it's not congruent, it's not the same, but it's similar to the original, okay? It has the same angle measures, and the side lengths are in proportion to the original, to the pre-image side lengths. Alright folks, hopefully this was helpful. Can't wait to see you tomorrow.